All right, so I'll confess, I don't remember what I said at the end of the last video of where I would go to next with this code, but I think the thing I ought to do next is turn the active piece from a simple square into an actual Tetris piece so that I can play around with the rotation part, so that I can get the part with the active piece checking for whether it's at the bottom and for clearing out the bottom row. I think that's a good next step. And I think for right now, I'm just going to go with my favorite Tetris shape, the T block. So that's the one that's got 3 blocks in a row and then 1 block coming off from the center there. And this one's fun because you can rotate it. You can test basically everything you need to for the code with this one. And then later we'll add a section of code where we randomly select the Tetris piece to use. So I want to think about how we're going to keep track of the way this piece is functioning, its position, its rotation, etc. So I went over to this reference, the Tetris fandom wiki. Always trust the fandom to get you useful information. And so the T block has as its center point this, the sort of middle square, the one in the middle of the row of 3. That's the point it rotates about. So I think that's the point I should record as its position. Let me grab my pen here. So we're going to record this as the position. So that'll be the actual position of the item that we call the active piece. It won't be a shape in VPython. It'll be a collection of several shapes. So we'll use that. And then we'll need to record basically the relative positions of each of these things. 2 to either side, and then 1 to a perpendicular side. And so as this thing rotates, we'll need to rotate the yellow dots around the pink dot, basically. So let's start by separating these two, because this is no longer what active piece is going to be. Active piece is going to be a list. And I've learned the way I like to work with lists is start with an empty list and then just add pieces to it, or add items to it. So we'll have active piece dot append, and then we'll add each of these boxes. So let's start with just the central box here. So this is going to be the pink one right here that is actually being highlighted. That's convenient. And so we'll have this as its starting position, which is good. And then I need to add 1 piece to the right. So let's copy and paste this. And I think the way I'll do this, rather than kind of manually, crunch through all of the positions, I think what I'll do is get rid of this part, and I'll say active underscore piece of 0, because that's going to be this first part that we have. And then we'll say plus vector 1, 0, 0. That'll get me 1 square to the right. Okay, very good. I need 1 more close bracket. There we go. Copy, paste, and now we'll go 1 to the left, not 11 to the left, just 1 to the left. And now we'll go 1 upward. So this first one here is going to be the pink dot. This one, that's 1 to the right, is going to be this yellow dot to the right. This one that's 1 square to the left, it's going to be this yellow dot to the left. And this one that's 1 square up is going to be this square that goes up. And now there's other stuff I need to keep track of for this. For example, I need to keep track of what kind of piece I'm working with, because that's going to impact how the rotation works up here. I haven't made a rotation algorithm yet, but we'll work on that in a future installment. So let's give this thing a name equals T. Let's see, is the convention uppercase or lowercase? The convention is in fact uppercase, so we'll go with that as a capital T, and that'll just help me figure out how we're going to rotate it above. And then there's another piece of information I need. Down here I refer to the active piece's height. Now when I had a single square, that was easy to keep track of because that was just the square's height. That's a natural thing that already occurs for a box in VPython. But I'm not working with a box anymore, I'm working with a list. So I have to give this list active piece a height. So let's say active piece.height equals, and this is going to have a height of 1, 2. And then I should also give this piece a width, .width, since I'll need to be able to check whether it can go left or right. So this thing currently has a width of 3. So if you think about this thing as taking up space, it's got a height of 2 and a width of 3. Is there anything else that I refer to with the active piece as an attribute. So let's see. We'll find all the occurrences of active piece dot. Oh, we need to give a position, obviously. So let's see. We'll say active piece dot position equals, and then we'll just use this thing here. Copy and paste. Dot pos. Oh, and these need to be dot pauses up here. It's not going to know how to add a square to a vector, or a cube, or a box to a vector, I should say. I'm thinking of them as squares in 3D. Of course, they're boxes. Okay, let's find any more active piece dots. Control F. Oh, nope, not of 0. Not of 0, excuse me. I'm looking for active underscore piece dot. Find the next one. Okay, that's good. Find the next one. That's good. Find the next one. That's good. That's good. That's good. That's good. Oh, I'd already had a width reference, so that's good that I went ahead and added it. Okay, I think we're okay then. Let's see. Let's make sure this works the way that I would like it to. Oh, wait a minute. So let's think about this. When I move this to the left or right, I'm updating this position here, but I need to be able to move all of the pieces. Okay, so let's think about this. For square in active piece, square.pos.x plus equals 1. So that way I'm doing whatever I do to this, I do to this thing here. And then I need to do the same thing on the command to move right. We're pressing left or A. And we'll make this a minus equals 1, just like we have over here. Okay, let's give that a try. We're not doing any rotating yet. I can clear my little drawing there for now, I think. Oh, that did not happen the way I intended it to. Right, I need to make the whole thing fall down, don't I? Okay, so on this animation now, all right, active piece.pos.y minus equals 1. Okay, so here I'm going to need to do the same kind of thing that I did before. We'll do a paste, get this guy aligned, get this guy aligned. And now we're doing .y. Okay, and we need to be subtracting. I wonder why it made that hole in the middle. I don't know. Guess we'll find out. Control 2 to run. Okay, that's weird how this is falling twice as fast as the other one is. They're at least responding to my left and right. Oh, okay. I think I know why it's moving that twice. Because here, I haven't just set these equal to each other. I have linked this position to this position. So when I update this one, it automatically updates this thing. So I actually want to do this backwards. Let's do Control X. I actually want to do this the other way. That I want, let me show you what I mean. I want to set the active position piece here. Steal this vector. X, Control V. And then here, I want this to be active underscore piece 0.pos. Okay, I think that should fix it. Cannot read property pos of undefined. Active underscore piece.pos. Okay, it doesn't like... excuse me. It doesn't like the fact that I'm trying to assign a position to a... Oh, right. This needs to be active underscore piece.pos. Okay, there we go. Let's try that now. Okay, it's now taking those as one object. Very cool. We've got this thing moving left and right. I have a little problem where this isn't letting me go all the way to the edge. Okay, that's because it's checking it in terms of this thing's width. Excuse me. So I actually want that to check... Not in terms of the piece's width, but in terms of a cube's, in terms of a square's width. So that should actually be greater than or equal to 1, I believe. So let's do Control 2. It's starting up above the edge. I can refine that a little bit later. That's just the initial condition. Okay, so this is working out better. I'm able to get to the edge, but I can go past the edge, if that makes sense. Oh, I know what I need to do. Okay, this needs to be the width over 2, I think. We're going to make a width over 2. Let's give that a try. No, that does not work out for me. Okay, let's go back to the drawing board on that condition. So I have my, oh, I don't want that yellow. So I have my T block here, right? I want to be able to check whether it can go to the right edge of the wall. Basically, I want to be able to check for whether there is one or fewer gaps here. I want to check for whether this gap here is greater than or equal to 1. And so what I'm really checking is not the active piece's position. I'm checking the active piece's leftmost block's position. Okay, so I need to check this against the leftmost block, and then check this one against the rightmost block. Okay, that makes sense. That makes sense. Let's think about this, how I'm going to do this. Okay, so let's get the active pieces. Let's just go ahead and get that information up here. Active underscore piece dot, let's just call it LMB. So let's think about this. Let's make that equal to the right edge. Field underscore right. So we'll start out with that, and then we'll say for square in active underscore piece. Right, so we're going to check each of those, and we're going to say that the active underscore piece dot LMB leftmost block is equal to the min of the current leftmost block. Copy, paste. Please check me on my spelling of piece and shout at the screen if I've spelled it incorrectly. Comma, square dot pos dot x. All right, and then we'll do the same thing with the rightmost block. Dot rightmost block. Now we do the same thing over here. Oh, except this has to start at the left. Basically, this is the maximum value it can be. This is the minimum value it can be. So to check for a max, or set for a min, set it equal to the max first. To check for a max, set it equal to the min first. I know it's counterintuitive, but that is the way it works. Okay, cool. So now I'm going to change this conditional here. Instead of the active piece dot pos dot x, I want this to be active piece under. I want this to be active piece dot rightmost block, and I want this to be the active piece dot leftmost block. Right? I believe so. Boom, boom. Okay, moving left, moving left. All right, moment of truth. I am hitting the left key now. Now. Okay, good. I can't go that way, but I can go way past this way. Oops. I've got some problem on the moving the thing right. What did I do wrong? Oh, y'all didn't shout at me loud enough. I should have changed that min to a max. I zigged when I should have zagged. Okay, let's try that now. Okay, I am hitting the right key. I cannot go any farther. I'm hitting the A key. I cannot go any farther. Okay, perfect. All right, we've got that part set up. Let's get rid of my diagram there. And now let's think about this part at the end where we check for the bottom of the playing field. Here, we want to look for, I guess, all the squares at the bottom. Okay, let me get back to the drawing board now. So I've got my Tetris piece. All right, let's just think of it in terms of the simple shape, because again, I haven't started rotating it yet. So I've got my Tetris piece here, and let's suppose I've got another block somewhere down here. Could be under any one of these. Okay, I think the best way to do this is going to be to check each and every block for whether there is a frozen block or frozen square directly underneath it. Because when I do end up rotating this thing, let's look ahead for a second. When I do end up rotating this thing to, say, this direction, I need to be able to check for whether there's a block in this space and whether there's a block in this space. So when I think about checking all of these, I don't really want to have to worry about what direction I'm rotated in. I think it would be easier to just check all 4 squares, because there's only 4 squares in a given block. I think I should just check each of the 4 squares for whether there is a frozen block underneath it. Because these squares, they're not in the list of frozen squares yet. I have this list of frozen squares right here that I can check against. Okay, let's do this then. I already have this set up. So let's just set up another loop around here. So let's say 4 square in active piece, just like we've had before. So this is going to check over every square in my active piece. Then I can loop over the squares in the frozen square. So let's indent these folks. I can get rid of this carriage return there. And then what I can do, instead of referencing the active piece, I can reference the squares.pos.y. Oh dear, I've got square referenced twice. Let's call this piece square. There we go. If piece square, etc., and then we'll have, for this one I'll have piece square as well. Piece underscore square. It's coloring the pi blue because it's trained to do that to look for the constant pi, but we don't have to worry about that because we're working with squares, not circles, and you only get pi with circles, right? So I've got piece square, piece square, piece square. Okay, I think what I'm going to do is change this one also to frozen square, just so that I'm being as clear as possible for my future self, especially since I just changed. Nope, I'm good on that. Excuse me. Yeah, I want to do this here. So I've got piece square minus frozen square, and then piece square height here. Piece square and frozen square here. Falling equals false. Okay, so I've got frozen square there. And then I want to check for the bottom. So I think I can just move this thing into this loop because I want to check for whether any of the squares are at the bottom. So this is going to turn into piece underscore square like before. Copy. Then we'll do this one here. Okay, cool. And then I need to add the active piece to the frozen squares. I need to add each of the squares. Yeah, we'll need to expand later to become squares that make up the piece. I am doing that now. I'll get rid of that note. So now we say, so now we're out. So here we're keeping track of the loops, right? So here I was inside the while falling loop. This is after we exit the while falling loop. So this is after either of these falling equal false gets triggered. So we'll say for piece underscore square in active piece. Frozen underscore squares dot append piece underscore square. Okay, I've got consistent spelling all around there. And just for my future self's sanity, let me change this square into piece square. Sounds like p squared. Let's see. For square in this, yeah, piece square. P squared, just so that I'm consistent across the code. I think that'll be better. Yeah, I think that's good. Okay, let's see if this does what we think it will. Okay, we are still falling. We're moving left. Can't escape. Moving right. Can't escape. Now the moment of truth. Will this entire piece get stuck at the bottom and add to the list of frozen squares? Boop. Okay, that worked. Now we can see if it's added to the list of frozen squares. If this one stops directly on top of this one, then I believe we are good to go. Excellent, excellent. Just for safety's sake, let's check to make sure this one stacks on top of the other one. If it does, then I'll run one more test just to make sure that we're okay. I see I'm probably going to need to come up with some way of creating an outline for these things because you can't quite tell where they like where one square ends and one begins. I mean, you can tell, but like when if these parts get filled in, it's just going to be a mass of stuff. Let's let this one fall and just make sure it doesn't get upset by any of these folks. It shouldn't, because that wasn't happening before. Okay, cool. Okay, I want to do one other thing. I want to test whether these things can interlock with each other. So I want to see if this square can rest on top of this square here. Should fall on top of that, right? I might overlay a grid over this or something. Yep, we should be able to get this locked in here. And boom, we did. Okay, wonderful. So excited. Okay, this is awesome. I think the next thing that I'll work on is getting a full row to clear out. I think that's probably the next logical thing to look at. And then we'll work on rotating. So I'll do one of those two the next time. Oh, that was unfortunate. It got caught. It did not check for itself correctly there in the in the gap there. Watch. Let's see if that happens again. Boom. Okay, so it kind of depends on when you click it. Okay, so I'll need to test that a little bit, make sure that that turns out okay, because I was able to cheat a little bit there. Anyway, like I said, I think the next thing I'll do is work on the rotation and clearing out the completed rows.